Hello everyone. On this video we will be covering the cross product of two vectors. Okay, so to start off, what if we let a vector equal three components, a number 1, a number 2, a number 3, and b vector equal the three components b number 1, b number 2, and b number 3. Or if we want to write it as a linear combination, a vector can equal the first component times the I unit vector plus the second component times the j unit vector plus the third component times the k unit vector, and b would be the same thing, first component times the I unit vector plus the second component times the j unit vector plus the third component times the k unit vector. Okay, so if we let those represent vectors in space. Okay, well, it can also work for two-dimensional space. Obviously, this is 3D, but it can work in either space. Okay, we know the cross product of vectors A and B, go ahead and underline that, is, okay, so the cross product of A and B is equal to component 2 of A and the third component of B minus the third component of A times the second component of B. Then we have the third component of A times the first component of B minus the first component of A times the third component of B. Okay, put a comma there. Now we have the first component of A times the second component of B minus the second component of A times the first component of B. Okay. Or if we wanted to write that as a linear combination, we can say our cross product of A and B is equal to A2B3 minus A3B2 times the I unit vector plus A3B1 minus A1B3 times the j unit vector plus A1B2 minus A2B1 times the k unit vector. All right, so don't stress too much because you don't have to memorize this. I'm going to show you a way to kind of easily calculate it. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and go to our next page. Okay, so to calculate the cross product, use the determinant formula of a 2x2 matrix. Of a 2x2 matrix. Okay, so if you're a little foggy on that, I'll go ahead and go over it in case you forgot. So the determinant of a 2x2 matrix, so the determinant of a matrix, let's say, with values A, B, C, and D, will equal A times D minus B times C. Okay, so we go upper left, lower right, minus upper right, lower left. All right, so we're going to use this technique to find our formula, or to calculate our formula. Okay, so the cross product of A and B is equal to, so the first thing we're going to do is we're going to draw three 3x3 matrices. So the first row up top is going to be I, J, and K. Then the second row is going to be all of the components of the A vector. So A1, A2, A3. And the last row will be all the components of the B vector. B1, B2, B3. Okay. Then we're going to go minus, and we're going to draw that out again. I, J, K, A1, A2, A3, B1, B2, B3. Okay, then we're going to do one more, but this time it's going to be plus I, J, K, A1, A2, A3, B1, B2, B3. Okay, so that's just starting out. All right, so what do we do now? Now on this one, the first one, we circle the I. Then we cross out everything else in that row and in that column. And for the second one, we're going to circle the J. And we're going to cross out everything else in that row and everything in that column. Then for the last one, we're going to circle the K. And we're going to cross out everything in that row and in that column. Okay, so what we're going to have is we have A2, A3, B2, and B3 is the only thing that's not crossed out. So we have A2, A3, B2, B3, and we're going to multiply that by the I unit vector. Okay, so we have minus, then we're going to do the same thing. We have A1, A3, that's not canceled out. So A1, A3, B1, and B3. All that times our J vector. And then we have A1, A2, B1, B2. And all of that, of course, times our K vector. All right, now once you have that to where you now have a 2x2 matrix, you're going to use the determinant technique. Okay, A times D minus B times C. Okay, so this one you have A2 times B3 minus A3B2. And that's times the I vector minus A1B3 minus A3B1. That's the J vector plus A1B2 minus A2B1. And of course, that's times your K unit vector. Sorry about that. Give you a couple of seconds to catch up since it was off screen for a second. Okay. Now, you can use this form of the formula, or you can distribute the negative, and that will give you A2B3 minus A3B2 times the I vector. If you distribute that negative, that becomes plus. The A3B1 becomes positive. So A3B1 minus A1B3 times your J vector plus A1B2 minus A2B1 times your K vector. Okay, so you can use either one of these forms of it. All right. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and look at some of the properties of cross products. Okay, properties of cross products. Okay, so for our first property, the cross product of vector A and B will equal the negative if you switch them around. So the negative of the cross product of B and A. Okay, so property number 2, the cross product of A and the cross product of B and C is equal to the cross product of A and B plus the cross product of A and C vectors. Okay, so the third property, we have a constant C times the cross product of A and B vectors will equal that constant times the A vector, and you can take the cross product of the B vector, or you can move that constant next to the B vector. So the cross product of the A vector and the constant times B vector. You'll get the same answer either way. All right, so our fourth property, if you have an A vector and the cross product of a zero vector, it is commutative, so you can say it's the same as a zero vector and the cross product of an A vector. Either way, your answer will be a zero vector. Okay, so the fifth property, any vector that's a cross product of itself is going to equal a zero vector. Okay, now the sixth property, if you have the A vector and you want to find the dot product of the cross product of the B and C vectors, that's going to equal the cross product of the A and B vector and the dot product of the C vector. Okay, and last but not least, our seventh property. If you have your A vector and the cross product of B and C vector, that's going to equal the negative of the dot product of the A and B vector times the C vector plus the dot product of the A and C vector times the B vector. Okay, honestly, the more complicated ones you probably won't use, like number 7, but it's one of those good to know type things. Okay, so just to show how these pop up, I'm going to go ahead and prove the first one. Proof of number 1. Okay, so if we have our cross product of the A and B vector, okay, we know that that's equal to A2 B3 minus A3 B2 times the I vector minus A1 B3 minus A3 B1 times your J unit vector plus A1 B2 minus A2B1 times your K unit vector. Okay, now if we switch those around, cross product of B and A, we'll see that if you use your 2x2 matrix format that we used before, you will end up with B2A3 minus B3A2 times your I unit vector minus B1A3 minus B3A1 times your J unit vector plus B1A2 minus B2A1 times your K unit vector. Okay, so if you factor out a negative from each one of these terms, you will end up with your cross product of A and B. That means your cross product of A and B is equal to the negative of the cross product of B and A. And the rest of them are proven pretty much similar ways. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and now I'm going to show you a different way to calculate the cross product. So it's just another way if the first way isn't something you want to do all the time. This is just another method. It's good to know both, but this is just a second way to do it. All right. Okay. Another way to calculate the cross product. All right. So we have the cross product of A and B. So what we're going to do is we're going to write our I, J, K, I, J, K. So we're just going to write that twice. I, J, K, I, J, K. Okay, then we're going to write the components of the first vector. So A1, A2, A3, A1, A2, A3. Then we're going to write the components of our B vector. B1, B2, B3, B1, B2, B3. All right, so what we're going to do, we're going to circle our I. Okay, now at this I, we're going to go down and to the right for our first I. For our second I, we're going to go down and to the left. Okay, so that gives us A2, B3 minus A3, B2. And all that times our I unit vector. Okay, now the difference is when we did the technique with the matrices, we had minus here. With this one, it's going to be plus. Okay, so you want to be careful of that. So we're going to circle the J's. Okay, now the J on the left, we're going to go down and to the right. And the J on the right, we're going to go down and to the left. Okay, so we're going to have A3, B1 minus A1, B3. And that is times our J vector. We're going to do the same thing with our K. We're going to go down and to the right, and this one down and to the left. So K is going to be A1, B2, A1, B2 minus A2, B1 times our K vector. Okay. Now, if you wanted it to match the formula on the previous page, all you have to do is factor a negative out of both of those. So move that up. So you have A2B3 minus A3B2 times your I vector. Minus, so if we factor a minus out of this one becomes positive. So you have A1, B3. We make this minus negative and factor a minus out, it will become negative. So minus A3, B1 times your J vector plus A1, B2 minus A2, B1 times your K vector. Okay, so both of those would work. It all depends on which one you want to use and if you want to go through the extra trouble of doing that. But honestly, when you're actually solving a problem, let me go back to our second page. When we're solving a problem, honestly, this will be the one we use most. Okay, and I'll show you on the example. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and go to our first example. Okay, so let's say, for example, find the cross products. Okay, so for problem A, we want to find A cross B. Okay, now for problem B, we want to find B cross A. And for problem C, we want to find the cross product of B and B. Given by A vector is equal to I minus 2J plus K vectors. And B vector is equal to 3I plus J vector minus 2 times the K vector. Okay, now for B and C, we're not going to use the properties. We're just going to go ahead and work them out. Okay, so for problem A, running out of pencil lead here. Here we go. Problem A, we have the cross product of our A and B vector. Okay, so we have our I, J, and K. Remember, you want all of the components of A on your second row. So we have 1, -2, and 1. And the components of B in our third row, which is 3, 1, -2. All right. Now we're going to do the same thing we did when we didn't have them there. We're going to circle our values here, and then we're going to cross out the ones in the column. Okay, but we're not going to actually do that. You don't have to do it each and every time. Okay, so that's going to equal, if we circle the I, and say we block everything in that column, we're left with -2, 1, 1, -2. Okay, so we have -2 times 1. Oh, kind of jumped ahead a little bit here. -2, 1, 1, -2. And that is times our I vector. Okay, you have minus, if we cover up our J, we have 1, 1, 3, and negative 2. 1, 1, 3, negative 2. And that's going to be times our j vector. And then that's plus, so we get our k, cover that k up. We have 1, negative 2, 3, 1. 1, negative 2, 3, 1. And that's times our k vector. Okay, so now we go ahead and use our determinant of a 2 by 2 matrix. So that's negative 2 times negative 2 minus 1 times 1. And that's times your I vector minus 1 times negative 2 minus 1 times 3 times your j vector plus 1 times 1 minus negative 2 times 3. And that's times your k vector. Okay, so that's going to equal 4 minus 1 times your I vector, negative 2 minus 3, or minus negative 2 minus 3, I'm jumping ahead a little, times your j vector, plus 1 minus negative 6. Could have put plus, but kind of taking it step by step. Okay, so that's going to equal 4 minus 1 is 3, so you have 3i minus negative 5, so that's plus 5j plus 7k. Or you can just make the vector 3, 5, and 7. Okay. So now let's go to problem B. We calculate B cross A. Okay, and again, we can always go to the property, and that would be a couple of quick seconds, but we're just getting some practice in actually calculating. Okay, so B cross A. Again, we're going to use our IJK. So IJK. Our B will go on the second row now because that's first in our calculation. So B will go first. So that's 3, 1, negative 2. And then A will go on the last row, which is 1, negative 2, 1. All right. So that will equal, we cover up our I. We have 1, negative 2, negative 2, 1. That's 1, negative 2, negative 2, 1 times our I vector. Oops. Minus, we cover up our J. We have 3, negative 2, 1, and 1. 3, negative 2, 1, and 1 times your J vector plus, running out of room, try to squeeze it in. We cover up our K. We have 3, 1, 1, negative 2. So 3, 1, 1, negative 2 times your K vector. All right. Okay, so for our I vector, we have 1 times 1 minus negative 2 times negative 2. Times our I vector. Minus, we have 3 times 1 minus negative 2 times 1. That's times your J vector. plus, we have 3 times -2 minus 1 times 1. And that's times your k vector. I don't know why I don't start further to the left. I always end up with zero room on the right. Okay, so if we go ahead and calculate that, that'll be 1 minus, well, this is negative and negative is positive, so that's 1 minus 4 times your I vector minus 3 plus 2 minus negative times your j vector plus -6 minus 1 times your k vector. Okay, so we end up with, don't really need that parentheses there, -3 times your I vector minus 5 times your j vector minus 7 times your k vector, or -3, -5, -7. Okay, so if you notice, our cross product of A and B is equal to the negative of our cross product of B and A. Okay, so you have 3, 5, 7, and then -3, -5, -7. All right, so we're running out of room here, so we'll go to our next page. If you're still writing, feel free to press pause. But we're going to go ahead and finish this up on the next page. Okay, so for C, we want to find the cross product of B and itself. Okay, so what I want you to do is I want you to press pause and try this one on your own. All right, so I'm assuming you've pressed pause and you've worked this one out on your own. So let's go ahead and try this. We have I, J, K. Okay, so we have 3, 1, -2, the components of the first B, and 3, 1, -2 is our components of the second B. Okay, so that's going to equal, if we cover up our I, we have 1, -2, 1, -2. So 1, -2, 1, -2 times our I vector minus, we cover up our J, we have 3, -2, 3, -2. And that's going to be times our J unit vector. And if we cover up our K, we have 3, 1, 3, 1. So 3, 1, 3, 1 times our K unit vector. Okay, so if we go ahead and use our form, so you have 1 times -2 minus -2 times 1 times our I vector minus 3 times -2 minus -2 times 3 times our J vector plus, we have 3 times 1 minus 1 times 3. 3 times 1 minus 1 times 3. And that's times our K vector. Okay, so we end up with -2 minus -2 times our I vector minus, we have -6 minus -6 times our J vector Then we have 3 minus 3 times our k vector. Okay, so that's just going to be 0 times the I vector minus 0 times the j vector plus 0 times the k vector, which is just a 0 vector. Okay, which is why the property is if you get the cross product of itself, it's a 0 vector. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and go to the cross product of unit vectors. Okay. Cross product of unit vectors. Okay. So first, we have the I unit vector and the cross product. The j unit vector is going to give us the k unit vector. And if we have the j vector and the cross product of the I unit vector, that's going to give us the negative k unit vector. Okay. Same thing if we have the j unit vector and the cross product of the k unit vector, that's going to give us the I unit vector. Or if we have the k and j unit vector, cross product of that will give you the negative I unit vector. And last but not least, you have the unit vectors of k and I will give you j. So if you flip those around, I and k will give you negative j. All right, so they're pretty quick to prove, so we'll prove number 2. The rest of them are proven pretty much the same way. Okay, so if you have the j and I, that's equal to, you have I, j, k. For your j, remember that's 0, 1, 0. And for your I, that's 1, 0, 0. Okay, so that's going to equal, we cover up our I, we have 1, 0, 0, 0 times our I unit vector minus, we cover up our j, we have 0, 0, 1, 0. 0, 0, 1, 0 times our j vector. Now if we cover up our k, we have 0, 1, 1, 0. And that's times your k unit vector. All right, so if we go ahead and do 1 times 0, 0, minus 0 times 0, 0, times our I vector, minus 0 times 0, 0, 0 times 1 is 0, times our j vector, 0 times 0, 0, 1 times 1 is 1, times our k vector. Okay, so you can see here we have 0, 0, negative k. Okay, so that's going to equal the vector 0, 0, negative 1, or just negative k vector. Okay, so that's the proof for number 2. And again, the rest of them are proven in a pretty similar way. But just like before, I'm going to show you a little bit of a shortcut. Easy way to calculate. Okay, so what if we this one we're going to go left to right. Okay, so we go I, J, K. We kind of block that off a little. I, J, K. Okay, so if we combine the cross product of I and J, we'll get K. Okay, so we have I and J, we'll get K. So we go I and J will give us K. Okay, we know that J and K will give us I. Okay, so we know that K and I will give us J. Okay, and again, you're going from left to right. IJ gives us K, JK gives us I, KI gives us J. Okay, now we're going to go from right to left. Again, just write IJ, K, I, J, K. Okay, now when you go right to left, your answers will be negative. Okay, so KJ gives us negative I. JI gives us negative K. If you go IK, it gives us negative J. Oh, got to put my vector right there. Okay, so that's how you would calculate your cross product of unit vectors. Alright, so hopefully this video made sense, and I will see you on the next video.